Okay, let's look at this question. Straight line L1 has an equation y equals 3x minus 6, and straight line L2 is perpendicular to this. So already we know something about the gradient. And pass through that point. Find the equation to form y equals mx plus c, where m and c are constants. Okay, so the gradient of L1 and L2 must times together to give you minus 1. So gradient from line 1 and line 2 must times together to give you minus 1. And therefore we know this one has a gradient of 3 because this is in y equals mx plus c format. There's m and there's c. C is where it crosses the y-axis, m is the gradient. So we can write down 3 times m2 will equal minus 1. So m2's gradient will be minus 1/3. Now I'm going to use, to get this y equals mx plus c format, I'm going to use another equation, y minus y1 equals mx minus x1. That's all in brackets, where this is this is still my gradient here, and this point here, these are where you cross, sorry, this is a point on the line which I've given here. So let's put those in. So I'll get y minus a y value on the line, which is 2, equals m, which is minus 1/3, times x times an x value on the line, which is 6. So minus 6 from there. So let's just highlight those so you can see where everything's coming from. So we know what corresponds to what. Okay, so this is the gradient. These are a point on the line. Now I need to get it in y equals mx plus c format. So let's multiply out the brackets first. Minus 1/3 x. Minus 1/3 times minus 6 will give me a plus. 1/3 of 6 is 2. And I'm going to add 2 to both sides now to get y on its own. And add 2 to this side, I get 4. So I'm now in y equals mx plus c format, and I've got the equation of my line. The lines L1 and L2 intersect at a point C. Use algebra to find the coordinates of C. So let's do that. Well, the easiest way is I know that, I'm just going to get another highlighter to overwrite. Let's go for this one. So I know that y equals all of this. I know that the y also equals all of this. A bit bigger to take a little longer highlight. So therefore these two green things must equal each other if we're going to intersect at a point. So we make them equal to each other. So 3x minus 6 must equal minus 1/3 x plus 4. So let's get all the x's onto one side and all the other values onto the other side. So minus third, so I'm going to add a third x onto this side, so I get 3 and 1/3 x. And I'm going to add 6 to both sides, so lose that from that side, I get 10 on this side. Now you can do this on your calculator, but bearing in mind if you're doing C1, the module C1 as part of the AES syllabus, you can't use a calculator. So how are you going to do this? Well, 3 is going to be 9/3, and this is 10/3, therefore. If that's 9/3 and you've got 1/3, you get 10/3. Then suddenly this all becomes a lot easier to work out. Times that by 3, you get 10 on this side and 30 on that side. Divide by 10, you get x is 3. Now we need to find out y. The easiest equation probably to use to find y is y equals 3x minus 6 because there's no fractions in there. And most people are not a big fan of fractions. So let's use the y equals 3x minus 6. So y equals 3 times 3 minus 6. That's 9 minus 6. So y equals 3. So the intercept, so the point C is at the point 3, 3. Now we want to calculate the exact area of the triangle ABC. We know the lines cross the x-axis at points A and B respectively. So we need to find the points A and B. That's where they cross the x-axis, so that's where y equals 0. Well, let's go back and have a look at our two equations again and see what happens when y is 0. In this one, if y is 0, I get 0 equals 3x minus 6. So therefore we can solve that down here. Let's put that 0 equals 3x minus 6. So I get 6 equals 3x, and I get 2 equal to x. Add 6 to both sides, divide by 3, x equals 2. Now this one, here we go, 0 equals minus a third x plus 4. So let's add the third x to the other side. So you get a third x. To get rid of the negatives, it's always easier to deal with positive numbers. Third x equals 4, so times both sides by 3, and you get x equals 12. Right, let's draw a little sketch of what's going on. We've got crossing the x-axis at 2, crossing together at 3, 3, and crossing the x-axis at 12. So we just draw a little sketch of that. So crossing the x-axis at 2, and we're also crossing them at 12, and we're intersecting at the point 3, 3. So we have this triangle. Okay, and we want to find the area of this triangle here. Okay, let's do that using half base times height. So the base length here is going to be 2 away from 12, which is 10, and we can see the height of our triangle is 3. So the area equals a half, it's a great looking 2, half times by, we got 10 times by 3, which is 15 units squared. Half times 10 is 5 times by 3 gives us 15 units squared.